Ash Robafet ungiphindile loko device yami ngirekhodile mara ile-strike. Mara anyway, so speaking of 1.2 this time. So now we have 1.2 as solve for x and y simultaneously. If 2x minus y is 1 and your y squared minus xy equals x plus 7. So this is a simultaneous equation because we have to solve for x and y simultaneously. So the idea behind the simultaneous equations is that we have two graphs. In this case, we have a linear graph, and this is a quadratic graph because everything the square, the term that has a square is positive, it is facing up. So khona la lama graph lawa yithi wahlangana khona, and where they meet they have the same xy values, the xy, they have the same coordinates obviously on our coordinate plane. So la is equal. So now I'm going to use this to my advantage. So now you have to make, obviously, label your equations. This is your equation 1 and this is your equation 2. So you can say this is your graph 1 graph 2. Equation 1 equation 2. So now you have to make either x or y a subject on your linear graph. So I'm choosing to make y a subject here, meaning I must isolate y. So ngimusa that side, beka negative, makafika this side uzoba positive. Thatha lo 1 ngimusa ngada, beka positive uzoba negative. I still have my 2x this side. So y now is 2x minus 1. So this is my third equation now. Remember, they have the same xy as same xy. So I can take this y, because now y is 2x minus 1, and then I can substitute on my second equation along 1 upon y. So my second equation is y squared minus xy equals 2x plus 7. And then where I see y, I substitute 2x minus 1 in brackets. So I have to say 2x minus y squared, y wami now. Not about y 2x minus 1. Don't be confused. And then I have to say minus x, there's my y again. I have to substitute 2x minus 1 in brackets. And then this will give me x plus 7 because I say common y. And then now I have to expand. So I'm going to show you shortcut because mentally the same thing. So square your first term, 2x squared, so 4x squared, and then times the 2 or multiply the 2 terms. 2x times negative 1 is negative 2x. Double it becomes negative 4x. And then square your last term, minus 1 squared is positive 1. And then here I simply distribute negative x times 2x is negative 2x squared. And then here I have negative x times negative 1, which will give me positive x. And then this side now by another hux, where positive is over negative, where positive is over negative. And next this side, so it's equal to 0. And then now I simply have to add my like terms. About x squared, 4 minus 2 is 2. X squared about x. So this x cancels this x, and then I have o minus, because x minus x is 0, and then I have only o minus 4 as my x, and 1 minus 7 is negative 6. So this will be 0. Then now I have to factorize. So whenever I factorize in Java function over the last video, you go in this order. Is there a highest common factor? 2 goes into 2, 2 goes into 4, 2 goes into 6. So 2 is my highest common factor. I can factor out to 2, or I can just simply divide every term by 2. So 2 divided by 2 is 1. So like I said, x squared. Negative 4 divided by 2 is negative 2x. And then negative 6 divided by 2 is minus 3. And 0 divided by 2 is 0. Now I have to simply factorize as a trinomial now. I have my x and x as on x squared. Your last term there, factors of 3 are just 1 and 3, so 1 and 3. And then now I have to get to negative 3 when the bigger number between the two follows the sign of the middle term. So 3 will start to negative. And then if I want to get to negative 3, when I multiply these two, 1 times negative 3 is negative 3. So 1 is positive. And then now this means your x is either negative 1 or your x is 3. But let's solve for x and y simultaneously. So we'll solve for x. Now it's time for you to solve for y. So now you take your third equation now. Was it y equals to? Angeke usastruggle that will factorize when. You simply take your third equation with y equals to 2x minus 1. And then substitute for negative 1 la. So let's see, if I substitute for negative 1, it will be 2, and then 2 times negative 1 is negative 2. Negative 2 minus 1 is negative 3. So this is my first coordinate where these two are equal at minus 1 and minus 3. And then for my second coordinate, I have to say y equals, we're still using the same third equation, 2x minus 1. Substitute your other x value now. So this becomes 2 times 3 minus 1. 2 times 3 is 6, and then 6 minus 1 is just 5. And then my second coordinate is x3, y5. Easiness. And then now let's go to 1.3. For extra practice, you can make your x the subject here and then solve for x and then do the same procedure and see if you don't get the same answers, provided you did everything correctly there, meaning you factorized properly, you added properly, as long as I'm careless mistakes, you should get the very same coordinates which I got, which were minus 1 and minus 3, 3 and 5. Yeah. So now 1.3. But the diagram below shows a circle with center O. So now immediately my mind goes to my circle geometry. Basically, that passes through vertices triangle ABC. So there's a triangle here. Center is O. This suggests to be diameter. AB is the diameter. So that's diameter. So immediately, wonke ama-theorem where circle geometry involve with diameter will come to mind there. So I observe it's a semicircle now. The theory of semicircle, if this is a diameter and it subtends an angle, the circumference, the angle layer is 90 degrees. The reason you're calling it angles in a semicircle or something. So this is my A, B, and C. And then but to AC is x plus 3. I can draw a diagram. 5 minus x. So now, since this is a right angle triangle, Pythagoras, back to grade 7, back to grade 8 or 7, somewhere there. So now, Batini calculates the value of x that will make AB. So AB as 9, and Pythagoras can help us figure out AB in terms of x. So now, I said C is 90 degrees. Angles in a semicircle or something means semicircle. And then this allows me to now use Pythagoras. My longest side equals to short side squared. Short AC squared plus BC squared. So the long side squared equals to short side squared plus short side squared. And then this is obviously Pythag. Unless I mix paper 1 and paper 2, which means you have to provide reasons. You don't just write C is 90 degrees. Why? You don't just use Pythagoras. Why? I'm sorry. So now I can solve for AB1. What's my AC value? My AC value is x plus 3. And then this must be squared. And then my BC is 5 minus y x, which must be squared. So now again, I'll use the shortcut because recording here is not IOMA. So square the first term, it's x squared. And then times the 2, it becomes 3x. Double it becomes 6x. Square your last term, it becomes 9. And then plus square your first term, 25 times the 2, negative 5x, double it, minus 10x, and then square your last term, becomes x squared, and this is my AB squared. And then now add your like terms. X squared plus x squared is 2x squared. A pool plus A pool is 2A pools. 2x plus x squared. X squared plus x squared. X squared plus x squared is 2x squared. So now 6x minus 10x is negative 4x. And then 9 plus 25 is 34. And then now I can what must I dial now? Martin, calculate the value of x that will make AB the diameter a minimum length. So whenever they talk about a minimum, if it's not calculus, you must know what they are referring to in quadratic equation. So obviously guys, this is a quadratic function, and because our a value is positive, we know it's a smiley face. And then in a smiley face, we have a minimum value, which is our turning point. So now how do we find the x value at turning point? Your x value at turning point, you get it by using the equation x equals to negative b over 2a. So this is the x value at the turning point. xtp is negative b over 2a. And my b value is negative 4 over 2. My a value is 2. So now negative times negative is positive. So this will be 4. And then on my denominator, 2 times 2 is 4. 4 over 4 is 1. So the x value at the minimum for this function is 1. So the x value that will make AB, which is the diameter, the minimum length is 1.